Okay, everybody, please welcome Ivan Čuljak. Enjoy.
Hvala. Woo. Okay, so you can obviously tell I like the color. So thank you for coming. Good morning to everyone. It's morning for me. Hello, Luca. Morning for you too. So the talk today is not about going to the cloud like Facebook does or Google does. It's about going to the cloud with your normal project. That's why we're talking about 101. So, white. Yeah. You need some sunglasses. So, my name is Ivan Čuljak. I'm from Croatia. What I do officially is I build cloud solutions. What I do in reality is basically shout at clouds and try to fix something someone else broke before me. And I've been doing it for a really long time. Yeah, you really do need those sunglasses. I'm a freelancer. I'm an Azure MVP, but Azure aside, what I'm going to talk about today is applicable to any proper cloud. Let's go with it. So AWS, Google Cloud, Oracle, not so much, but let's not talk about Oracle. So keep in mind, this isn't a talk for you if you want to build Facebook, Google, whatever. We're talking about simple solutions which you can use to build your daily projects, which will allow you to do something which will make you feel really cool. Because are we all developers here? No sysops guys? Yeah, I feel sorry for you, mate. So the evolution of app hosting goes like back in the day, in the 90s, with the beginning of the 2000s, we were using shared servers. We were renting servers in our favorite local web hosting company, whatever. And that worked for a while before someone developed and deployed the first lousy script, which killed all the resources for everyone. So the next step was, let's get a dedicated server. That worked, but we needed more. So we went to, let's get a farm of servers, which did the task. But the problem was someone actually needed to maintain all those servers. Someone needed to deploy all the stuff to every single server. And no one really liked it. Another problem was that those servers weren't really used. Because if you deploy to a single server, a single app that is in reality getting 2 requests per day, you're wasting a server. So someone on the financial side of the business came with the idea, hey, can we use those servers much more dense? That's where virtual machines come in. So instead of having an app per server, we've started deploying virtual machines to servers and then apps to those virtual machines, which made the operational cost so much lower. But we needed more. So we've started, yeah, this doesn't really work. Okay, so we've started deploying virtual machines over a farm of servers. So when you have a farm of servers, you can deploy basically a hypervisor above them and then just keep deploying virtual machines. The problem was that someone actually needed to maintain those virtual machines and that we wanted to deploy apps even more dense. So we came up with containers. Not Docker containers, but much before that, we were using containers on Linux. It worked, and it drove some sysops guys really mad because they were in charge of maintaining containers that didn't have any self-healing, any orchestration, anything. They were just deploying containers, and if some broke, they were available on the phone to fix them. Next step, welcome container orchestration. The most familiar one is probably Kubernetes to all of you. Anyone heard of Kubernetes? Yay, full room. So what you get here is we have hardware. On top of those, we have virtual machines. On top of those, we have a container orchestration tool, on top of which we have containers, which is great. And if you're a sys guy, let's not go with a dream come true, but it's fun to maintain it. But from a developer perspective, all I want to do is build an app, deploy it, make it run, forget about it. That's my dream come true. That's why this talk isn't about serverless, but that's the serverless goal. Forget about it. Focus on your core thing. And that's what we're going to be talking about today. So your developer vulgaris usually have, anyone heard of Hetzner? Yay. Okay, so it's a hosting company where you can get cheap VMs. So what a usual developer does is rent a VM, deploy an app there. So where is the database going to be? On that same VM. Where's the storage going to be? On that same VM, etc. And you get the point. So everything is being hosted on a single VM, which you are maintaining manually. Meaning that if you have the joy of using a Windows server, and you're really eager on the update button, so you update it, and your server broke, well, tough luck. You need a whole lot of coffee. By the morning, you'll be up and running. The problem here is there's no redundancy. But some people think that if you do a SQL server backup, that will solve all the problems. And I've seen people doing SQL server backups. Do you know where? To the storage of that same virtual machine. So that doesn't work. And we need to move away from it. Where we're going to move is the cloud, the promised land. So why cloud? That's not a typo. It means if and only if you implement it properly, you're going to have all those benefits. You're going to have auto-scaling. So some load comes in, your machines are going to scale. What you'll be doing in that time, you'll be drinking coffee, you'll be watching TV. It's not your problem. It will scale. In theory, we'll get there. You'll have a load balancer. So when you're using virtual machines, the main problem is you either have to write a script or you have to manually add the machine to a load balancer when you spin up a new machine. Over here, you're getting it within the price. So managed services are the cloud way. We're not talking about virtual machines. If you're using virtual machines on the cloud, you're either doing it wrong or you're on AWS. So the idea is that there will be no downtime when you're deploying stuff. Why? Because when you're deploying, you can have everything automated to spin up a new machine, deploy there, run some tests. All of you are writing tests, right? Yeah, no hands up. So you deploy it to a separate machine, you swap them. The rollback, if you weren't doing any changes to the database, is a click of a button. So something goes wrong, or the test fails, it can automatically roll back, or not even swap to production. That's what you get. So the luxury of this principle is that you as a developer can develop your code, push it, make a PR, merge it, go home. Because the idea is, it will deploy if everything went well. It will not deploy if something failed. That means that up front you'll have a whole bunch of work to figure out how to make sure not to deploy something that won't work, how to make some minimal tests that will help you out. But after that, it's high life. You deploy you push your code, and sayonara, you're going home. No manual maintenance means no Windows updates for you. When there's a Windows update, when there's a Linux update, what the cloud does for you is spin up a new machine with the new image, the updated image, redeploys that code on that machine, swaps the machines. you don't even get an email because everything is working. Self-healing means that if something breaks, the cloud will spin up a new machine for you. And it really, really works. You get a firewall, and you get the DDoS protection. About that DDoS protection, it's not really cheap, but it does the work. So some people think that by going to the cloud, you are protected against DDoS with the idea that your cloud can scale so much more than the DDoS attack. In some cases, that's true. The problem is your bank account might not scale that well. Someone's going to need to pay for that. So it's cheaper to pay for DDoS protection, meaning that the cloud will just kill all those requests that were identified as the DDoS, than actually pay for the load. And if you're asking the marketing team, it can scale indefinitely. It can't, but they will try to sell it to you. So the basic setup here, since this isn't working, I'm going to go here, is to have some code in what we on Azure call an app service. It's a platform as a service. AWS calls it the Elastic Beanstalk, but I have no idea who's even using Elastic Beanstalk since it's really lousy. Yeah, on Azure it really works, because Azure wasn't really able to compete with AWS on the virtual machines front, so they went to V2. And whatever you deploy to app service, be it on a Windows machine, on a Linux machine, be it .NET, be it PHP, it works. They've made it work. That app service will be pinging a storage account on the AWS, you call it S3. We're going to use a managed database, and there's a chance you can use a managed Redis. So the idea is that whatever you do, you use managed services that can automatically scale. Why? You'll be optimizing that once you grow really big, when you'll be managing your own infrastructure. But up until then, just let it scale automatically. So as for Redis, on basically 90% of projects, there's no Redis, because why the hell would we need it? There's no CDN because, hey, it works. Yeah, it works with your single request. So optimize your stuff with Redis. Another thing is, people are afraid of the cost of the cloud. So when you go to the cloud, when we previously were using virtual machines, the idea was that there's a single virtual machine per environment. So you have, or multiple per environments, but you weren't really sharing them. So the idea was you pay per environment. With a platform as a service, that's not really needed, unless you do some ugly load tests. So you can have an app service and add slots to it, meaning that you will deploy multiple apps to that same platform as a service at the same cost. So your cost isn't increasing, you're just adding slots. But keep in mind, you're using the same underlying infrastructure, which means that if you do some load tests on your QA environment, you're going to kill production. So just keep it in mind. You're either optimizing the price, or you're optimizing the load. But this allows you to easily swap between slots. So what you do is you deploy your code to the dev environment. If it works there, you just click a button or run an automated script which swaps that whole slot to the other slot, which means your dev code goes to test. After test, you go to QA. After QA, you can go to staging or immediately to production. There's no downtime, because all it does is it switches. Microsoft used to call it VIP, VIP swap, virtual IP swap. And every single person thought they were special because it's a very important person swap. It wasn't. So what it does is, there's an app deployed. When you click swap, it starts routing IP requests to another IP address. Your config files are also being swapped because you are configuring secrets per slot. meaning that you can swap like this, roll back like this, and it works. So that's OK for a monolith, but sometimes your monolith isn't good enough. So what you call to help you out are queues. You have them on all clouds. You call functions. You may call them lambdas. And you call some other managed services. So the idea is that if your monolith, if your API can't handle the load, or if there's something really long to process, you just offload it to a queue. Something else will take care of it. The benefit of going to a queue is, and remember, we're talking about 101, which means we can pretend to be naive and not think about some really ugly edge cases. You can offload all the work to your queue. When something gets that message, start processing it. If it fails, the message will get back to the queue. Meaning that whatever you do, if your process fails, you will not lose any single request. After some number of retries, your message will go to a queue, to a dead letter queue, where you will be able to manually inspect what went wrong, but you will not lose anything. As for functions, it's the easiest way to offload some background work from your API, meaning that your API will be quick and responsive, and that you will be able to process, be it resize images, be it ask the AccuWeather.com what's the weather, or something to another computing model. And that computing model, again in theory, can scale indefinitely. It can't, but that's a topic for another talk. Another thing you might want to consider is making your system event-driven. And there's a difference in concepts. When you're using a queue, what you're saying is you're giving out commands. You're saying, hey, you, do this. Because you usually have queues per type of task. For example, print out the invoice, or do this, do that. So you're adding a message to a queue and basically saying, do this. With the event-driven approach, you need to shift your mind a bit, because all of a sudden you're not saying print out the receipt, you're saying the purchase was made. Whoever listens to that needs to react to it. And if something that's in charge of printing out a receipt is listening to messages which says a purchase was made, it will just print it out. Which means that you can scale your cloud so much more, because for events, you can use Event Grid. AWS has the same thing, only with a different name. Meaning that you're pushing events to a central place which can scale more than basically all of your products will scale. And that's really, really useful. Offloading work usually goes in two ways. One is the API can send a message to the queue, gets a request, sends a message to a queue, something else processes it. Remember, queues are usually bidirectional, meaning that you can reply. So the function sends back a reply, and your API was waiting for it. Why was the API waiting for it? Because you're developing an old school API where you're only using requests and responses. But by offloading that work to a function through a queue, you're not wasting your threads on the machine that's an API. Another model, which is, well, it was modern 10 years ago, but now it's standard, is you get a request to the API. The API basically validates whether you can actually perform it. If so, it pushes a message to a queue. A function listens to a queue, a function does something, and then the function calls the webhook. The webhook which was provided by the client. So both work. The webhook can also be the Azure event grid, meaning that you can push stuff there saying, we're done. And these are the two common principles of offloading work. When you have multiple apps, and people usually do have multiple apps, you can go with an app per platform as a service, which kind of costs money. And you might not want to do that. So what you can do is you can deploy multiple apps on the same app service plan. And you can basically host multiple apps on a single virtual machine, if that works for you. But you're not even seeing those virtual machines underneath. You're only seeing a number, you're not maintaining them. And each of these apps can have a number of slots. You don't even have to have the same number of slots per app. So you just deploy them. Since the cloud is kind of intelligent, they will warn you, hey, you're using too few virtual machines for the number of apps you've deployed. Perhaps think about scaling up, or it can scale up for you. But when you have multiple apps, you will have multiple URLs. And you don't want to tell to all your clients, if we're talking about this part of work, call this URL. Otherwise, call that URL. You basically want to group them. The way you group them is you place something in front of them. What we do is we place the API management, which is, again, a managed service. So when you place the API management in front, you can expose all your APIs through it. Not only expose them like through a load balancer or a usual API gateway. What you can do is you can add logic to it. Logic like, let's rewrite our request, or let's rewrite a response. So why would you want to rewrite our request? Perhaps what you're hiding behind is the New York Times API, and you want to add your API key. Why would you rewrite a response? Because any of these apps doesn't know they are being exposed through the API management. So when you're doing REST properly, you're sending back media URLs. You're sending back links, how to get to the next one, how to get to something else. And that URL is the URL of that app. It's not the URL of the API management. So you want to rewrite all those URLs to make sure all calls are going through the API management. API management also allows you, and that's the bottom app, to expose an API from a virtual network, meaning that you can hide your whole thing in a virtual network and allow only the API management to connect to it and communicate, which is really useful, especially when you're an enterprise, but even in other situations, because although the cloud is public, you don't want to expose everything to the cloud. Just a side note, when you're using a managed database, at least on Azure, and you go to the firewall rules, there's a switch saying allow Azure services. So what you think that means is, hey, Azure will allow all my services to connect to the database without me whitelisting IP addresses. That's normal, right? What it actually means, everyone from Azure can access my database. Everyone. So all your attacker needs is a virtual machine on Azure, and your database is exposed. So if you place your database in a virtual private network, if you hide everything and expose it through the API, that's the easiest way for you to do stuff. My favorite feature on the API management is throttling. So what you can do is you can have multiple pricing models. For example, a bronze subscription, a silver one, a gold one. And then you can configure that whoever has the bronze subscription is limited to a single request per minute, or in parallel. So when someone starts using it and someone says, hey, this is slow, we're limited, you just point to the pricing table and say, hey, buy the silver one. So that's how you do business. OK, scaling. Number one, you have a constant workload. A no-brainer. You've deployed something, there's a constant workload. You're happy. There's no need for scaling. The second one is kind of periodic, meaning that during lunchtime, if you're a website selling lunch, during lunchtime, your machines need to be scaled up. Otherwise, they will be scaled down. But it's normal. It's not crazy. It's not all of a sudden. But the third one, and Luca's going to love this one, is a once-in-a-lifetime spike, which means you can't account for it. And you really can't, because we're not talking about getting 50% or 100% more requests and having that ramp up in a few minutes. We're talking about having 10, 50, 100 times more requests ramping up within a minute. So all you can do when you're in that situation is, well, have a cup of coffee, or beer, or rakia, whatever you want to. Fourth one is crazy. Why? Because your load doesn't make much sense. It's going up and down without any dynamic you can figure out, meaning that you should always over-provision for a bit, and that your automatic scaling won't be fast enough, because automatic scaling works, but it's not so fast. In those situations, you might want to figure out how to handle scale controllers. And you might want to scale up on events. What does that mean? If you remember the idea, the offloading slide, you can scale up the rest of your infrastructure when something comes to the API. So instead of scaling in a reactive manner, when something is hitting your services, you can scale up the rest of the system as soon as there's a request in your system, because you will know that in a second we'll need those functions. Start scaling them up. The fifth one is, I have no idea who's using this. How can you scale for that? Enjoy. That's outside of the 101. Because one day you'll have a zillion requests per second, the other day no one's going to use your service, and you have no idea how to provision for it. OK, scaling storage. Storage is a fun thing to use, because when you get a storage account, it's over-provisioned for you. Most services won't ever throttle a single storage account. But when your storage account, that single storage account, isn't enough for you, you don't have an automatic way to scale up. The only thing you can do is add yet another storage account, but then your code needs to handle them, which means it's time to start sharding your services and make sure that a portion of them is going to one storage account, another portion is going to the second one. Scaling a database can be done in two ways. One is, if you have a single managed database, you can scale it up and down, but not for any given number of times per day. You can do it 3-4 times a day, meaning that you can't scale it up and down every 5 minutes, because they won't allow you. Another way is to use an elastic database, meaning that you are paying for a certain number of resources, and then you are deploying your databases within that pool. And your databases can scale up and down indefinitely within that pool. It also makes for some cost savings. Scaling apps is kind of easy. All you have to do is deploy it. So if your workload isn't ramping up really quickly, you can just deploy them. App service will take care of adding more virtual machines and scaling them down. And then you want to go worldwide, although your service is only being used in Balkan. So what you want to do, first of all, is deploy the same thing to multiple regions, because at the first moment, you don't need some redundancy. You only need the app to be as fast as possible near your client. So you're deploying the same thing to multiple regions, which are the closest ones to your clients. But in that case, every single region has a different URL, and you don't want to do that. So what we usually needed to do is add a traffic manager in front of it. But now we have a really cool service called Front Door, and Front Door will do the traffic manager's job of sending your requests to a region which has the lowest latency to your client. Not only that, Front Door has the DDoS protection built in for a really small price. Otherwise, DDoS protection on Azure costs around $2,000 per month. So not really the cheapest option. What Front Door also has are edge entry points. So there are around 15 to 20 regions in the world, if we're talking about Azure, but there's over 130 entry points to front end, which means that your request will go to the nearest point and then continue traveling through Azure's network. First of all, your requests are hidden from the Chinese government, if you're in China. Second of all, they are going so much faster through Azure's infrastructure than if we're bouncing between Germany, Austria, Netherlands, France, and then in the 10th hop, we're getting to Azure. When you're using storage and when you're using databases, you need some replicas. You do want them, trust me, because once they will fail. So you need a replica. And the easiest way to do that is to have a single node, which is a read and write node, and have read replicas. What you're doing here is you're always pinging the same URL, and the data is usually being sent to the main database, which is in the same region as your service. But if that database or storage fail, you will be automatically redirected to a replica, and that replica will become a read and write replica, which will continue replicating to the second one. If that second one fails, if the first replica fails, you're only stuck with a single one. So in theory, you might run out of storage, but not going to happen. So this is really a no-brainer. It works. When your main one gets back, all the data gets replicated back, and then you are connected to it. From your code perspective, you're using a storage account. It works for you. And then things go south. When your apps get killed or don't work for some reason, there's no automatic fallback. That really isn't. So what you do in these cases is you allow the front door to route all the data to another region, and that other region will scale. Problem solved. It will take some time, the latency will be a bit bigger, but it works. When your queues fail, that's a problem. So you just wait for them. When your queues fail, in a normal situation, you just post a message, we're having some maintenance, please come back a bit later. People get happy with that. But there's a problem if your requests fail. So there's a request which came into your region, it's being processed, and then something fails. And that request might be lost somewhere, and you want to continue it. That's a situation where the cloud won't help you. That's a situation which you will have to develop by yourself. You will have to develop some redundancy for it. You will have to send requests to multiple regions. You will have to have some functions watching in other regions, watching over the other region, whether the task is being processed, etc., etc. This is when things get complicated. This is when you're trying to become a Facebook and not just yet another create, read, update, delete app. So the next step here is Kubernetes, but the managed one. You don't want to manage a Kubernetes, trust me. So you just spin up an Azure Kubernetes service or an AWS one, and you have Kubernetes. But what you're going to do with it is what's going to separate you from yet another app deployed on the app service. Why? So Kubernetes can deploy multiple applications as containers. From a perspective of a few slides back, it works the same as the app service plan, meaning that the app service plan is good enough for you in most cases. But the idea is that Kubernetes scales virtual machines up and down as you need them. So from a perspective of app service plan, it works really good, and you don't need to complicate your life with Kubernetes. But when you get some load that has a really high ramp, you won't be able to tackle that load with virtual machines, because it takes virtual machines to spin up and provision them there at least 2-3 minutes. And first of all, you need to figure out, hey, now is the time to start spinning up. So what we do in those situations is we burst out to container instances. Container instances on Azure are the equivalent of Fargate. So those are, if you ask Microsoft, those are serverless containers. If you ask AWS, they are just containers. They are not serverless. So the idea here is that when you need to burst out some load really fast, you tell to the cloud, hey, I need 10 containers, 4 cores, 32 gigs of RAM now. You will get them within a minute. You will be able to handle the load. The latency might be a bit higher than if you've had the infrastructure already provisioned, but you will be able to handle the load. A cute thing for me as a .NET developer is that I can have Linux containers and Windows containers. So if we're moving some .NET framework stuff, it can work there. But if we're talking about spinning up serverless Windows containers, we're not talking about a minute. We're not talking about 10 seconds. We're talking about 2 minutes, at least. So Windows containers are a thing to avoid, but you can use them while you're migrating your project. Another cool thing with Kubernetes, unlike App Service Plan, is that you can have different sizes of virtual machines. Meaning that one of your containers can be deployed to a group which has fast CPU. Another one might be deployed to a group which has a lousy CPU, but a whole bunch of memory, because it's memory intensive. Yet a third one might be deployed to virtual machines with GPU availability. And you can mix Windows and Linux stuff. So all of this is the next step, which isn't available on the app service plan. Why would you want to use virtual machines instead of container instances? Because container instances are so much more expensive per minute, per second, but they are available right now. So the idea here is when there's a huge load, you burst out to container instances and start scaling up virtual machines. As you scale up virtual machines, you're scaling down container instances. The way to do this in Kubernetes is kind of automatic, but also you need to tackle some stuff with Helm. Anyone heard of Helm? Okay, so avoid Helm. There's a really cool startup called Pulumi, made up of AWS people, Microsoft people, Google people. There's a developer on Pulumi used to develop Terraform, and he said, Terraform isn't good enough, let's build something better. So with Pulumi, you can handle this whole thing by writing real code. Real code meaning Python, Go, TypeScript, C# soon. So you don't need to write yet another markup language. You can write the real code. Why would you want to write the real code? Because with a real code, you can do some business logic. You can access, for example, in your infrastructure provisioning script, you can access a database and check which client needs which virtual machines. And then based on that data, you can spin up infrastructure. So it's a really, really cool thing to do. And with that, thank you so much. If you have any questions, shoot.
Thank you. We have one question.
Oh.
Tips to avoid vendor locking with cloud. Easily switch from AWS to Azure or bare metal.
Oh, mate. Oh, okay, so let's solve the bare metal thing first. Bare metal isn't the way to go to the cloud, except if you're an enterprise invested in VMware. So Azure is bringing the capability of lifting and shifting stuff to bare metal. Okay? That solves the bare metal thing, but that's not for you. Don't go bare metal or buy a server and place it under the desk. As for vendor lock-in, if you follow some common sense how to do stuff, you will not lock yourself that much in. But if you try to build something that's abstracted from everything, you will spend so much more money on building a not vendor locked-in solution than it would cost you to migrate from one cloud to the other. There's not a thing as a, we're really multi-cloud without a dependency on a single vendor. You're always dependent on a vendor. So go with a cloud. It's always best to start with a single cloud. Use some stuff that's available on other clouds. Perhaps abstract your code a bit, but go with a single cloud. Because if you're abstracting too much, you're losing capabilities. And all of a sudden, some really great solutions become really lousy because you're only using stuff that's available across all the offerings. So a vendor lock-in is something business people are most concerned about, but don't buy the hype. Just go with a single cloud. Then if you really need, go to multi-clouds. But for example, if you go with Azure and then decide not to use Active Directory and you use Okta instead, Okta locked you in. There's not a situation where you won't be locked in. Just make sure you can migrate within something in 3 to 6 to 12 months, depending on the size of your cloud.
That's all?
That's all.
No more questions. Woo! Thank you once more, Ivan.